Hi guys, welcome to today's video. This is going to be all about properties of materials. Now our world is made up of lots of different things. Alright? We have metals, we have non-metals, majority of our world is made up of composites, and those are things that are made up of other substances. Today I'm just going to be looking at 5 properties that we look at when we're talking about materials. Not every material just has all of these properties or displays them, okay? But we're just going to go through and give a brief definition and understanding what each of them is. So the first thing I'm going to be looking at is solubility. Now when we talk about solubility, it's important to understand that you can talk about solubility in either polar substances, and water is a really good example of a polar substance, okay? Or we can have it in something like non-polar substances. Non-polar substances are sometimes referred to as organic. Alright, a common non-polar solvent that we use is something like dichloromethane. Okay, that looks like this, that's CH2Cl2, whereas polar ones such as water, sometimes they're called aqueous solvents as well. But when you're talking about solubility for a material, it's important to define whether it's soluble in polar or non-polar. If you just simply say something is insoluble, what are you talking about, right? Are you talking about that it's insoluble in water, or is it insoluble in oil? Okay, so solubility is the ability of a solute to dissolve in a solvent. Now a solute is a solid material, and the solvent is the liquid that we're dissolving it into. Okay, it can also be, if you're talking about 2 different liquids, you can talk about the solubility of one into another. If they don't mix, the term we use for that is immiscible. Alright, so immiscible liquids are ones that don't mix. So solubility is the ability to dissolve into another substance, okay, and we generally talk about it if it's soluble in a polar substance or a non-polar substance. Now when we look at thermal conductivity relates to ability to conduct heat. Okay? Now we know that there are some materials in our world that conduct heat really well, and metals are a really good example. Okay? So metals conduct heat really well. And the reason that metals conduct heat really well is that the atoms that make up a metal are close together. Okay? Now what that means is that when you start heating the metal, right, whatever part you start to heat, what happens is those particles gain energy and they start to vibrate. Now those particles, those atoms can then pass the energy along to the atom next to it by vibrating, okay? And that allows the heat energy to conduct all the way through the material. Now if the atoms aren't close together, or if the atoms can't vibrate, right, you end up getting a material that's what we call a really good insulator. Okay? An insulator is something that does not conduct heat. Alright, so a metal is a really good conductor, and when we're talking about thermal insulation, that means it's something that does not conduct heat. There's quite a few substances which are really good insulators that don't conduct heat. Okay, but we always refer back to how close the atoms are together and its ability for those atoms to vibrate and pass the heat down through the substance. So if it does conduct, its thermal conductivity is said to be high. If it doesn't conduct heat when you heat it up, its thermal conductivity is said to be low, and it's a really good insulator. Now if we talk about electrical conductivity, it's very, very similar, and we can keep looking at metals as good examples of electrical conductors. Okay? An electrical conductor is something that will allow an electric current to go from one end to the other. Now metals in this case are really good electrical conductors because they have what's called a free sea of valence electrons. So what that means is the electrons inside a metal, when you're looking at the structure of metal, they're not found within the bonds. They're actually free and mobile. They can move around. So what that means is that when you supply electric current at one end, and electric current is simply a flow of electrons, when you put electrons in at one end, the electrons inside the metal can transfer that charge all the way through to the other end because the electrons are free to move. Okay? If something doesn't conduct electricity, again it's an insulator. So rubber is a really good example of that because it doesn't have any free electrons that can transmit the electric charge. You can have solutions or liquids that conduct electricity. Okay? So a salt solution, for example, is a really good conductor of electricity, and the reason for that is because it has free ions. And when you're looking at a salt solution, you might have, say, sodium ions in there, and you have chlorine ions in there. Those ions are able to conduct the electricity from one part of the solution to another. So electrical conductivity is the ability to conduct electrons. If it conducts electrons very well, it has a high conductivity and it's a conductor. If it doesn't conduct the electrons really well, it's an insulator, like rubber. Melting point and boiling point, these relate to how easily or how much energy is required to turn it from a solid to a liquid to a gas. Okay, so there's three states a substance can exist in: a solid state. If you heat that up, right, you turn it into a liquid form. Okay, and what we get through that is we know the melting point. If we heat that liquid further, we get to the point where it turns into a gas, and that's what we call the boiling point. Now, the melting point and boiling point, how much energy you need to put into that substance to turn it from a solid to a liquid or a liquid to a gas, is determined by what we call secondary bonds. Now, I do have some other videos around secondary bonds, so I suggest you have a look at those because there's different types. But the more secondary bonds it has, or the stronger those secondary bonds, the more energy is required to turn it from a solid to a liquid. So the more secondary bonds it has, or the stronger the secondary bonds, the higher the melting point. Okay? So you break those bonds to go from a solid to a liquid. When you then provide more energy, right, these particles now in the liquid are able to move around. Okay? Once those particles are able to move around a bit more, you supply more energy, you can break more of the secondary bonds holding them, and it turns into a gas. Okay? So the higher the melting point and boiling point, the stronger the secondary bonds, the interactions between the molecules, and the higher, more energy that is required. Alright, hopefully that's just been a quick introduction for you about the properties of materials. As always, if you've got any questions, just ask. Thanks, guys.